Next, please help me welcome our next speaker, Glen-Erik Cortes, who's the head of machine learning engineering at Royal Caribbean, where he led the design and implementation of their ML platform that's currently in use by all data scientists at the company. After Glen-Erik's talk, we're going to take a 20-minute break, and we'll be back at 3:30 Eastern, 12:30 Pacific to discuss data reliability from three perspectives in a live panel. You'll also have the chance to ask the speakers any questions that you want, so make sure to tune in for that. I look forward to seeing you all there, but first, I'm excited to turn it over to Glen-Erik.
Hi, my name is Glen-Erik Cortes. Excited to be here presenting on behalf of Royal Caribbean Group. I'm a ML engineering manager there, and I'll be talking about accelerating development and delivery of machine learning solutions using sandbox environments, version control, and modular design. A little bit about me. I have an MBA from IE Business School. That's IE Business School is ranked number 6 MBA worldwide in 2010 when I studied there. Still always kind of top 10. Also, Six Sigma black belt trained. So a lot of my thinking and methodologies are influenced by the kind of streamlining processes, and because of that, so you'll probably, if you know about Six Sigma, you'll probably see why I did certain things here. Started coding in 2001. I have 15 years of analytics and AI experience, 9 years at Procter & Gamble in the analytics and shared services space. My last role there was as market estimates and projections leader. I have almost 4 years at Royal Caribbean in July. My current role is I'm the ML engineering manager. I created the ML engineering department, which is currently growing. And we're hiring, so you'll hear more about that at the end if you're interested. I led the design and adoption of the ML platform that's now used by all the data scientists. Before, everyone was working on their laptop, so transitioning them from there to the cloud was a big achievement. And now that ML platform has grown, and it's now being used for data engineering and the general data platform rebranded as Alpha Platform. So that's pretty exciting. A little bit about Royal Caribbean Group and our department. So Royal Caribbean, right, it's a cruise company, and cruises are basically floating cities. So you have all the different kinds of use cases you could possibly imagine in a regular city, except with a big difference that we have all the data, right? It's centralized data. So we know how many people are on the ship, who's on the ship, things like that. So profiles. So it's great for machine learning because you have all the data centralized to do predictions and so forth. Our analytics and AI team, our department, is a horizontal organization. The leader reports directly to the CEO. And that's very nice because when you have a separate department, like all the data scientists embedded, you don't get so much collaboration between the data scientists. And this horizontal organization includes data science, data engineering, BI, data governance, and the platform, right? So we serve pretty much all the business teams. So some of those are finance, HR, marine operations, marketing, medical, onboard revenue, revenue management, supply chain, trade. So it's a bit, we have a lot of different clients that we serve, right, within the business. Now, for this chat, I'm going to be talking about how applying CI/CD to ML solutions, so sandboxing, Git flow, and automated DevOps. Also, the importance of data locality and modularizing the data and modeling pipelines in batch job solutions. So when talking about applying CI/CD to ML solutions, we're basically going to be looking at combining Git flow and sandbox environments to automatically trigger deployments in QA and production environments. Some assumptions that I'm making here is, and should be the case for most businesses, production and QA environments should be isolated from development and from each other, right? Multiple people are going to be working on one project. Sometimes, if you're working independently, some of these issues, or the issues that this kind of solution solves, may not be as critical. Another assumption is that each project should have its own Git repository, unless it's not possible, right? And that's more of a best practice than an assumption. Azure Data Factory, you can't really do that, so that's an exception. And one thing I wanted to say is most of these, the approach I'm taking here is generic. So instead of trying to focus too much on the actual technology stack, more generic principles that you can also reapply in any technology stack. So if you're familiar with Git, right, hopefully you are. It's a version control tool, right? And there's branching involved with it. There's a methodology called Git flow, where you have multiple branches. There's a master branch or main branch, develop branch, feature branches, hotfix branch, and release branches. We took out the release branch to simplify things, but so that's pretty much the only difference. And how we have it set up is we have all the data scientists, right, or anyone can work on the feature branches in the development environment. And so we have a Databricks workspace instance, right, like separate from the QA Databricks workspace, separate from the prod one. And so in the development environment, they're working on their feature branch. And once they get to a good place with their with whatever feature they're working on, feature being a capability, right? They merge with develop or create a pull request, and depending on the project need, you could have a required approval there or keep it optional. It's more critical to have an approval going to production, but it depends on the project, right? The project need and the number of people collaborating and so forth. So especially the number of people collaborating. So once that feature branch is approved to merge to the develop branch, that automatically triggers the deployment of the code to the QA environment where testing can be done. And why do we want a QA environment, right? Like one easy example is in development, you may pull in a bunch of files and to do development, and then everything works well, but maybe one of those files isn't being refreshed, right? You forgot to set it up to pull the data from an actual source system. And when you go to a separate environment, that file won't be there, so it'll fail. And we want it to fail because you shouldn't be using old data, right? So things like that would be caught in QA. Now, after that, with a pull request to production, we automatically deploy to, sorry, a pull request to master, we automatically deploy to production, right? So the DevOps part is almost, you don't have to deal with it, which is really nice. Once it's set up, once you have it automated. And if there's an issue in production, right, you can create a hotfix branch that gets merged back to production without going through the full process, the same as Git flow. So one important note here is that the master branch always reflects what's in production, and we'll see why that's important. And yeah. So One question that I get asked a lot is why do I need a develop branch, right? So without a develop branch, here we have a flow of how it works. So the feature branch is what's in the development environment. Let's say you create a PR to the master, and then the release pipelines are what take care of going to QA and production. So what happens here is master can be ahead of production. So um, that's a problem, because if there's a bug in production, it's more difficult to troubleshoot because there's no branch that reflects the production code. And if you already merged your feature branch to master, and now you got to fix a bug, then you have to take that out of the master branch to continue. Or so it's a little bit more complicated, not as clean. It's always better to have the master branch reflects exactly what's in production. Another problem is QA happens after merging with master, right? So what happens then is the approval to merge with master is basically you're approving untested code. You could do some testing in development, right? But that somewhat encourages rubber stamping the approval, because you want to take it to the QA environment to test it, and so you just need a approval real quick. Now, what can happen or will happen is master becomes corrupted, right? Because if I merge a branch that's untested and something's wrong, then now the master branch has broken code, and someone else comes in and wants to create a branch, and they branch off of master with broken code, and now their code's also broken, or they're developing on code that doesn't work. So it's just a bad. It's much better and straightforward to have a master branch always reflect what's in production. Now, moving on to data locality and the importance of that. So I'm going to be talking about how to reduce or eliminate data loading times by separating the data migration work from the modeling work. And some assumptions that we're making here is the data is not already a physical file in a data lake. Multiple data sources are necessary. So cloud, on-premise, partners. On-premise just means that it's hosted on the company's servers or something. And then partners, other companies like Adobe Analytics or things like that, right? So another assumption, multiple people are working on one project, which was an assumption before as well. Data requirements overlap between projects. So sometimes we pull the same data, right? For different projects, use the same data. So moving data takes time, right? Large data sets can take 2 to 3 hours to import from an on-prem, and this is actually a particular project I'm thinking of. 2 to 3 hours to import from on-prem, because we use big data, or 40 minutes from Synapse within the same cloud. So just because someone says, oh, it's already in the cloud, doesn't mean it's ready for use, because you might have to move it within the cloud. So it's important to think about where the data lives, not just, oh, is it in the cloud yet or not, too. And here we have an example of a machine learning project, right? The data scientist starts working on a project. They pull data from different systems, on-premise or Synapse or wherever, and then pull it into a lake. Could be S3 bucket or ADLS as Delta Lake. Then from there, the development could happen in Databricks or Azure ML or anywhere else. And basically, you just open the file and do whatever you want, right? So at that point, there's really no waiting time. So to get the data out of the source system, if it's on-prem, in this particular example, it took 3 hours. And then from Synapse, actually the same data set took 40 minutes. So that's a lot of time to wait, right? So what happens when the data migration is done inside the machine learning project, like we structured it before? So there's bottlenecks and delays, right? 40 minutes to 3 hours, let's say, um, for some kind of data set, and we pull many data sets, right? So let's just say it can take 3 hours to pull the data set. And if you have to be rerunning that same pipeline to get to the point where you are in your modeling or feature engineering and so forth, then you have to wait quite a long time. Even if it was 40 minutes only instead of 3 hours or half an hour, it still breaks your concentration and you start working on something else and you lose your train of thought, or you're developing something and, oh, you need to make a little change and now you have to rerun the whole thing. It's not a very efficient workflow, right? So um, that creates delays in development, also delays in fixing bugs, right? The same, because it's the same process. It increases the load on source systems because, as you can see on the right, John, let's say he's working on feature B, he's rerunning that pipeline a few times a day, making little changes and has to rerun because the cluster shut down or whatever. And then Amy as well, right? Maybe she only needs to refresh a different data set that's a little smaller. Then Raja is testing the feature, a different feature, and there's the production jobs that are running. And we also don't want to affect production jobs. So having all these pulls run has to be done at different times or things like that. So it's and the load, the impact of the load is exponential, right? Because you have dev, QA, prod environments. You have the multiple developers, like we see here. And another thing we're not seeing in this diagram is that many projects use the same data. So multiply this times many projects, and it can quickly become an issue. So some of the benefits of separating the data migration is data access is instantaneous, right? There's a reduction of load on source systems. You're able to compare prod and dev runs, and we'll go into that a little bit more later on. We can change the data sources much easier. So let's say a data scientist is developing a solution. Well, it's better if the data scientist or ML engineer separates the data migration piece from the actual project work. And that can be a tool that we use to move the data, and it could be just copy the data set, right? Like whole thing, simple. Because data engineering team takes a little longer to catch up with development because they have to do a smarter data migration, right? Like with diffs between, okay, we're just going to pull the data that changed, right? Instead of the whole data set and things like that, and analyzing, okay, figuring out what data changed and how the table logic works takes time. So in the meantime, having these separate will allow for a seamless transition from just switching to the new without having to change any project code. Now, I noted that, so here we have separate repos, right? So the data migration would be a separate repo than the project 1 or project 2. And that data, right, from production, here it's simplified because we only have the final output of the data migration project, the production run, feeds into all the environments, right? Because typically we have, we always need production data for development. In software engineering, it's not always the case, right? Like you don't have to have a full data set to test an app, but for exploratory data analysis or training, model training, things like that, you have to have a full data set. You can't have incomplete data. So oftentimes in companies, we have to link to production because maybe in the test or QA environment, there's not complete copies of all the data sets, right? So, and this also applies to other data engineering jobs, I think. So this same methodology can also be used later on to add a feature store, because then you could separate out a feature repo from the modeling. Now, I wanted to go into a slightly different topic, but code modularity, right? So how to break down the pipeline into different steps with checkpoints to facilitate pipeline health monitoring, debugging, and speed up overall development. Some of the assumptions, batch job, right? Like it can be, we're going to assume that the use case is a batch job. Now for real-time API use case, it's just a little different, but we're not going to go into that because we have 30 minutes. So, but you can definitely use the same logic and just modify it for that. Business, another assumption is that business has a low tolerance for production bugs and downtime. We don't want the job to crash or incorrect predictions or missing data, things like that. So breaking out steps for quicker development and iteration, right? So it may seem that having all these things like, oh, we're talking about checkpoints and health monitoring, debugging, how is that going to help me speed up development? Well, it sounds like a bunch of work I'm going to have to do that's going to slow me down. But actually, once the solution's in production, this is going to make iteration much faster. And even the development part. So here in this slide, let's say we don't have the solution finished yet, right? Like there is nothing in production yet, and we're just doing development. So if we do, let's say, and we're also assuming that the data is already in the Delta Lake or whichever lake. So not coming from source systems, right? We already solved that problem. So now the data transformation step is separate from EDA, feature engineering, the training script, and so forth. So here you say like the output of, let's say, some data transformation, right? You pull a bunch of tables, join them together, and get kind of like a intermediate output. You save that intermediate output or intermediate outputs, in this case, 1 and 2, to a different Delta Lake, right? The input comes from production, but the output is going to dev, right? Because we're in development. So that can then be picked up and used by for EDA, and the EDA doesn't have to wait, doesn't have to rerun the data transformations in order to continue, or feature engineering and so forth. And this is especially the case once you have something in production. Maybe someone's now doing new EDA for something to come up with to improve the solution, while someone else is working on improving the feature engineering, or someone's working on refactoring the training script or things like that, right? So instead of having everyone pull those things separately or colliding with each other, we have the step is already run, so you don't have to rerun it. Now, and same for modeling, right? So you save the data set between feature engineering and the model experimentation. And then we use MLFlow to log the experiments in the development environment. And that's helpful. And then the training script logs the final model. So now, once we want to go into production, And you could already do this, but for MVP, this is going to be quicker for MVP. But once you're like, okay, my MVP is finished, I want to go into production, you kind of need some checks, right? Health and balances, or like checks and balances and so forth. But oh, one thing I forgot to mention. So when we save the Delta Lake as, or sorry, when we save these data sets, the intermediate outputs as Delta table, if you're familiar with Delta Lake, this might different for everyone, but there's it keeps history of the data sets. So what you can do is vacuum, like have a vacuum statement, which basically cleans the excess history from the lake for that file, and that way you're not endlessly accumulating data, but you have the default 7 days. So if every time you run the vacuum without specifying that, it'll tell you, okay, like you'll always have 7 days of history to go back and see, especially in production. So you'll be able to go back and see what happened if you need to. So once we're going into production, here's an example of a predict script, right? So like we have the input data, then we're going to be adding validation. So we still have version control of the data that was used for the predictions by saving that data set to the Delta Lake. We run some metrics on that data set, right? Like health metrics, like if it's missing rows or duplicates, or the data values, missing data values, schema validation. So like the data types haven't changed, no missing extra columns. And a third step we can do as well, that's a little bit more advanced, is adding business rules, right? And other automated testing. So an example of a business rule would be like, okay, what do we do if data is missing? So should we fail or continue? So like in the cruise industry, let's say we have, I don't know, 100 sailings, right? Sailing is just when the cruise goes on a trip, right? So 100 sailings in the future, and let's say, and all we're looking at is a prediction by sailing. You would say, okay, like if there's 10 missing, should I continue, or should the process continue, or should it stop? And it's like, yeah, maybe 10's fine. Like we can handle if there's 10 missing entries. But if there's only 50 sailings out of the 100 expected ones, hey, maybe even if the process, even if the ML solution would typically continue because it can still predict, right? Like there's no issue. We still might want to stop that and investigate. So it's not always just because it didn't break that it should continue, right? So we can also add logic like that to check. Some of the benefits of structuring the solution like this is you can quickly find the root cause of bugs, right? Because if there's missing data, right, and in the business comes back and tells you there's missing data, you don't have any business rules to alert or anything, but you can still go back and say and find, okay, where did that missing data come from? Did it come from the first step, or second or third, or where? And then you're already like, boom, going into the right part of your solution. Maybe you can either structure these with different notebooks or functions, etc. But you can go hone in onto that particular area, and you already have a checkpoint too. So, and versions of the data. So then it's very easy, and without having to wait to run the data set, or sorry, to run and get data and etc. You can see, okay, first where in the pipeline the data dropped off, and then you can analyze it further to see why, right? Because you have that data already without having to pull it. Other things, other benefits, right? You can proactively identify data issues because you have all these checks. So you can already see if there's missing data, but without it having to be something happen in production. And there's also transparency and confidence in the pipeline, right? And the health and performance of it. And you could show this in a dashboard if it's necessary, or other tools. And this is kind of like a non-traditional way of using MLFlow. I should have mentioned that at the beginning, right? Because like typically use MLFlow to log the model. We also have a model registry, so serve it, training script that trains a model in production. So then it's in the model registry. But without going too much into that, MLFlow has logging capabilities, and we can also use it for logging these metrics. So we have the training MLFlow experiment, but we can also have logging MLFlow experiment. So in the logging one, we have these metrics that kind of serve as a place to look at all these, what happened with the pipeline runs. Another benefit is, so we can always test parts, change and test parts of the code separately. That's I already mentioned that. Now, kind of bringing it all together, this is very cool. So now we can compare runs between different environments even. So we can say we have the input data that's the same, right? Because we're not pulling it every time, and that's version control. So we could even say, okay, get the version. But since we have the same input data, or we can use the same input data, we can say things like, okay, like we can run the feature branch, and if that is just a code refactoring, we're expecting the same output, right? So if the output is not identical, then we did something wrong in the refactoring. And if the feature branch is changing something, like changing the code, then we only have to analyze the changes in the output, right? Because you can say things like, show me only the rows that are different between the two data sets, and then another check that's like the rows that are have different values. So that allows for quick analysis of the change, because we're using the same input. That wouldn't be possible if we weren't. Now, and that can be an automated test. We don't have it automated as a test, but we do have those checks. And now, how to have the same input data, right? Like you can either run the dev QA code in tandem with the production code, and that's possible because now there's no more data bottlenecks, right? We got rid of that. So we're not calling the source systems in this script, because last thing you want is for your production job to go down, because now you're overloading running multiple big jobs against the source system in tandem, right? Like, so that wouldn't be possible if we hadn't separated that data migration piece out. And a different way of doing it is specifying or using specific versions of data from the delta history of the production inputs or outputs. And you can also compare the outputs of every step. So as we saw before, you have these steps where you save data sets, right? So you could compare those intermediate outputs between the environments even. So then you're really focusing on and quickly pinpointing where the difference is. Another thing to note is the prod intermediate and final output should be read-only in dev and QA, right? So like if you're So the data, the input data, all comes from production, but the output is going to different storage accounts, and that may be if you're in dev, it's going to a dev storage account or a dev database version, and all we're doing is writing there. So it doesn't matter if there's missing data because you're pulling the data from prod, but just writing to the other places as a testing ground. So then when the code moves, from a coding perspective, what the way we automate that is instead of having to change the code and say, oh, and dev do this and QA do that, we have a key vault that changes. We have 3 key vaults, 1 per environment, and the DevOps pipeline changes which key vault is used. So then if you're in development, the credentials and database that is being used in the key vault are pointing to the dev lake or database, and then in QA, the QA lake or database, and then in prod, so forth, right? It's very important to keep write access separate. So you don't want to have write access to production from development, right? You want read access, and you also want read access into the intermediate outputs because you want to be able to compare them, but you don't want to be able to write there because then you can affect the production jobs. So anything else? Yeah. So with that, I wanted to open the floor for questions, and if you want to reach out, please feel free with questions. My LinkedIn is Glen-Erik, or linkedin.com/in/Glen-Erik. Email is glenerik@gmail.com. Pretty simple. And if you want to learn more, we're hiring. So senior ML engineer, just go to the link or Google it for on the website, Royal Caribbean Group, senior machine learning engineer. And yeah, thanks a lot for joining, and I look forward to hearing from you if you want to reach out. Hopefully this information was helpful. Thanks a lot.